Hey there! We are going to explore two of very important things while solving equations in MATLAB. And this can be very useful when you are dealing with varieties of equations in MATLAB, or even while you are solving mathematical equations for your research purposes. So now let's dive into it. Here, first we'll start with SYMS command. Basically, it is the shortcut for constructing symbolic variables. This will be very useful when you are dealing with solving symbolic equations. Let me show you the difference between normal equation and symbolic representation. For example, here I am writing this normal equation, and when I run this, it shows undefined function or variable b, because it's obvious that we have not defined any variable, so it will clearly shows us an error. But when you use the syntax and mention all these variables b and c, and then again write this equation and then press enter. Now here also we are not defining b and c, but what it does, it takes this b and c as a symbolic variable. You can see here the type of variable, it's SYM. That means it's a symbolic variable, symbolic representation of a variable. Now let us take an example to better understand it. So here first I am clearing all the workspace variable, then I am clearing the command window, and then I am defining SYMS b and c as symbolic variable. And this is my expression. And now if I want to solve this expression, I need to use the command solve. Solve into bracket which equation I want to solve. The equation is A, right? So now when I run this thing, it shows a is equal to this, and now we are solving the a is equal to -5 into b raised to 2. So what it does, it solves this equation symbolically. So here I have two variables b and c. So when I solve this equation, it will solve the equation for the higher alphabetical number. The higher number is c, so it will solve the equation for c, and that is why we are getting answer as -5 into b raised to 2. Instead of this two variable, let us add one more variable, that is d, and we'll write 5 into d. And now let's run it. So here our solution is -b raised to 2 minus c by 5. So this is a symbolic solution, and it is solving for d, right? But now let's say you have some specific requirement that instead of d, I want to solve this equation for c. So what you're supposed to do, you need to write solve a, comma, you need to define the variable for what you want to solve the expression. Here in our case, we want to solve it as c. So we'll mention c and then we'll run. So now here you can see the expression is solved for c. The same way you can do with b. Instead of c, we want to go for b, and there we go. Here we have the expression for b. You can even solve the multiple equations in line. Let me show you what I mean to say. Here I am defining three variables a, u and v. Here su is my first variable, sv is my second variable, is equal to solve, and into the bracket, this is my first equation, comma, this one is my second equation. So here I am defining two equations, and now let's run this section. So we have the solution su and sv. You might be wondering that what I did, I have just run this particular section. This is a different section and this one is also a different section. How to create this section? Using these two plus sign. But what are the advantages and use of these sections? For that I have a separate video. You can watch that video to learn a very handy use of the sections. How you can use these sections and what is the importance of using sections. And the shortcut key to run only particular section is Control Enter. So it's very simple. Left hand side is our variable, then equal to solve, into the bracket our equation number 1, then comma and equation number 2. If you want to add more equations, then add comma and then upcoming successive equations. But the same way you need to provide the successive variables also. Now what if instead of this a, I have multiple values of a and I want to place that multiple values of a in this equation and then go for the varieties of solution. So what we'll do, we'll remove a from here, we'll add value of a changes from 1 to 10 in the step of 10 and then end. Let's run. So here we have 10 different values of SV and SU. But all these answers are symbolic representation of answer. If you want a real number in answer, then you need to write. And now run the same thing. But this time what I don't want to clear it all. Why? I'll show you why I'm doing this thing. So now let's run. So here it is, the symbolic representation of the answer. This is one of the way to represent the answer, but when you convert this symbolic representation to number, we'll get this numeric solution. So to convert the answer in numeric solution, you need to add this double. So I think this much is clear. Now it's time for the second interesting thing, and that is subs. S-U-B-S. This will do the symbolic substitution in equation. The syntax of subs is like this. Subs into the bracket S, old, new, bracket over. S is the equation or expression. Then this is your old variable and you want to replace old variable with the new variable. So here you need to place your new variable. So using this subs command, you can substitute your older variable with new variable, more complex, with more additional information, or with some numbers. So this is what you can do with subs. So now let's take an example of this for better understanding. So what we'll do, we'll use the same command here. Clear all CLC, sims B, C and D, and now we'll go for subs. So we want to substitute. So first you need to define the expression. So we are defining that we want to substitute anything in expression A. Now the older variable. For example, instead of this B, I want to use D, right? So my older variable is B, and the variable that I want to place instead of B is D. Now bracket over and let's run. So this is my solution. 5d square plus 5d plus c. But now you wish that instead of only b, I want to replace b and c both with some new variable. So for that, curly bracket, you need to define older variables b and c. These are the two older variables that you need to change. Then again comma, and now in curly bracket you provide your updated variable. For example, instead of b, I want to replace 3d, right? So what I'll write, 3 into d. So b will be replaced with 3d, and c, I want to replace c with d square. So here I'll write d square, bracket over, and now let's run. So here you can see this is my solution, 46d square plus 5d. So what is happening? B is replaced with 3d and c is replaced with d square. So in substitute you can use variable or combination of variable to replace with. Now here I can directly use instead of b, I want to replace 5, right? Control enter. So it will replace 5 with b. Sorry, I have written d, so instead of d it's 5. So 5 into 5 it's 25, right? So here I am replacing B, C and D with 5, 4 and 5 by 6. And this is the result of my substitution. So here in this video we have learned two important things. The first thing is symbolic representation with symbolic solution, and then symbolic representation with symbolic substitution. There is much more thing that you can do with MATLAB. You can solve varieties of equation with MATLAB.